Alright, in this video we're going to talk about Unit 4, Objective 4, the extreme value theorem. So what the extreme value theorem is going to say is that if f is continuous on a closed interval, a to b, then f is going to have both a maximum value and a minimum value. Now there's a little bit of nuance here when they say maximum value and minimum value. We need to know that the word value is going to mean y value. If they're asking for a location, like where does a maximum happen, they're asking for an x value, but if they say what is the maximum value, they want a y value. So value is going to mean y value in our case. Now, there's a little blank here so we can kind of draw a picture or two to kind of show what's going on here. So if we're on a closed interval, that means I have a definite starting point and a definite ending point. Now it doesn't matter what graph you draw that's going to connect your your beginning and ending point. If you're starting somewhere and ending somewhere, you're going to have a highest and lowest point. In this case, here's your lowest point, here's your highest point. So we have an absolute maximum up here and an absolute minimum down here. If we put points similarly in the same spot, kind of like that, we can make our graph go like this if we wanted to. And we'd have a minimum here and a maximum here, but we're always going to have both a maximum and a minimum. If we're on an open interval, that would allow us to write something like this, where we go up forever. We'll have a minimum, but we're never going to have a maximum value. So if we are on a closed interval, have a definite starting point, a definite ending point, we're going to have both a maximum and a minimum. Now, this is going to help us find absolute, or sometimes they're called global extrema. So where relative were higher or lower than everything in its general area, absolute or global extrema are going to be higher or lower than everything on the graph. Now, if we're going to find these, we're going to need to find all critical points and we're also then going to have to consider the endpoints. And the reason for this, if we look at this first graph, this endpoint was my absolute minimum. Absolute maximum happened here. This would have been a critical point because our derivative was 0 and we changed from increasing to decreasing at that point. So we need to look at not just critical points but endpoints as well. So remember, critical points are going to give us our relative max and mins. Sometimes they'll give us saddle points, but our relative max and mins are going to come from critical points. We're also going to need to check endpoints as well. Sometimes, like in this case, we'll get an absolute extrema from our endpoint. Sometimes, like in this one, that's not an absolute max or min, that's not an absolute max or min. So sometimes they will be, sometimes they won't be. Now, for our AP justification, if we're asked to find an absolute max or min, then we're just going to use an XY chart for our justification. Now, this differs from the number line because on an XY chart, what we're going to be showing is all of the possible places where we're going to have a maximum or minimum, and then we're going to show the y values. So if we're showing the y values of every possible maximum or minimum, we're showing what the actual maximum and minimum are. So our XY chart is going to serve as a justification for absolute max and min. Now, if this shows up on your AP exam, and it more than likely will, it's probably going to show up on a free response question, either something like what we're seeing here, or oftentimes we'll be having to find the maximum value of some certain object that we're given in the problem. But this one's a pretty standard, pretty common look at the absolute max or min problem. So it says the derivative of the function f is defined by that piecewise function there, where g is a semicircle of radius 2 and f of 0 equals 8. The graph of f prime is below. Now, for the interval -4 to 4, inclusive, find the maximum and minimum value of f. So a couple things that we need to point out here first. We know that this is going to be an absolute extrema problem. even though they don't say absolute minimum, absolute maximum. And the way we know that is because of the way they wrote the interval. We have less than or equal to. So we could end up writing it this way with brackets if we wanted to, because the brackets coincide to the less than or equal to. So they don't have to use the phrase absolute maximum and when they ask you to find the absolute maximum. They might hide it here with our inequalities. The other thing that I wanted to point out is this right here, value. So again, that's going to tell us we need to find a y value. So when we're going to do this, the first thing that we're going to try to find is our critical points, right? So we need to check all of our critical points and our endpoints. So critical points and endpoints are the things that we're going to be looking for. So critical points, if you remember, that's when our derivative is 0 or undefined. They tell us that this is the graph of f prime. So we're looking at the graph of the derivative. On the interval -4 to 4, there are no spots where my graph disappears, so it's defined everywhere. So there's no critical points where the derivative is undefined. But we're going to also need to check where we have other critical points where our derivative is 0. So our derivative is 0, so the y values are 0 at x equals -2. And right here at x equals 2. Our endpoints are going to be -4 and 4. They tell us that right there, so x equals -4 and x equals 4. Now we're going to need to make an xy chart, and we're going to need to find the y values of the critical points and endpoints, except we can be smart here. We only want max and mins. We don't really care about saddle points. So if we look at this critical point right here, our derivative went from positive values to positive values. So this at x equals 2 is not a maximum, nor is it going to be a minimum. So we actually don't have to look at that point. Because we know it's not going to be a maximum or minimum, we don't have to worry about it. So really all we need to do is make an xy chart, and we'll call it an x instead of y, we'll call it f of x chart. And we just need to find the y values for the x values -4, -2, and 4. So we have to think. We have f prime. I want f. So to go from f prime to f, we have to integrate. So I want to find -4. So I'm going to integrate from -4 to 0. And the reason I'm going to integrate from -4 to 0 is because I know something about f of 0. So -4 to 0 of f of x dx using our fundamental, f prime, because that's what we're taking the integral of. Knowing something about the second fundamental theorem of calculus, I know that this is going to be equal to f of 0 minus f of -4. So using this substitution here, f of 0 is equal to 8. So I can say 8 minus f of -4. But as we look at it right now, it doesn't really tell us anything because I don't know how to solve for f of -4. But we remember integral is going to be an area under the curve. We have the curve here. This little piece and this little piece here are going to cancel out. So we know that this integral is actually equal to 0. Because again, area here and here are going to cancel. So I know 0 is equal to 8 minus f of -4. So I know that f of -4 is equal to 8. So we just have to do that same process for -2 and 4. So we're going to integrate from -2 to 0. Again, we're using 0 because we know that of f prime of x dx, and that's going to equal f of 0 minus f of -2. We know f of 0 is 8. And if we look at our area under the curve, I have a triangle. Its base is 2, its height is 2. So 1/2 base times height, so 2 times 2 is 4. 1/2 of that is going to be 2, so we know that area is 2. So 2 equals 8 minus f of 2, so we know f of -2 is going to be equal to 6. And last but not least, we're going to integrate. This time we're going to start at 0 and go to 4 because, again, we need our 0 because of this, and we want to go from the smallest value to the biggest value. So f of x dx is going to equal f of 4 minus f of 0. We know that f of 0 is 8, so f of 4 minus 8 equals something. If we look at the picture over here, we can't really figure this out and that out very easily, but what we can do is look at the rectangle that we have right there. We know that rectangle has an area of 8, but I really only care about this stuff here. So if I'm going to get rid of that white piece there, that is the area of a semicircle. The radius of that semicircle is 2. So we're looking at 1/2 pi r squared, so 8 minus 1/2 pi times 2 squared, which is 4. 4 times 1/2 is going to give us 2 pi. So I know that the integral is 8 minus 2 pi. So that means f of positive 4, if we add the 8 over, is going to be equal to 16 minus 2 pi. So we have to find the minimum and maximum value. So the minimum value is 6 because that's the smallest number of these three things, and these are the only three things that can be max or mins. So our minimum value is 6. Our maximum value is, well, 16 minus 2 pi is going to be bigger than 8, so we'll say 16 minus 2 pi is our maximum value. So that's going to do it for this video. We will see you in the next one.